Sometimes our inequalities will look more like the equations in the last unit we did. Here's an inequality. X plus 4 is greater than or equal to 5. So I'm trying to find out what numbers can I plug in for x that make this inequality true. I can play with some numbers in my mind. I can try plugging in 0 for x. Is 0 plus 4 greater than or equal to 5? No, that doesn't work. If I plug in a 1 for x, 1 plus 4, that's 5. That's greater than or equal to 5, so that works. 2 plus 4 is 6. That's greater than or equal to 5. So I can go through and figure out that there are some numbers that work for x in this, and there are some that don't. I'd like to describe all of the numbers that actually do work for x when I plug them into this inequality. And to do that, I'm going to follow the same kind of steps that I did when I was finding out what numbers made an equation true. That is, I'm going to try and get x all by itself. And I can use the same steps to get x by itself in an inequality that I did to get x by itself in an equation. So in the inequality above, I could simply subtract 4 from both sides. When I take 4 away from both sides, I get x is greater than or equal to 1. So what this tells me is that any numbers that are bigger than or equal to 1 will make the original inequality, x plus 4 is greater than or equal to 5, anything bigger than 1 is going to make that inequality true. So you can apply the same, subtract the same thing from both sides, add the same thing to both sides. You can do those steps the same way with inequalities that you do with equations. In this section, you're just going to be adding and subtracting the same thing to both sides. When we start to multiply and divide both sides of an inequality by the same thing, things get a little bit trickier. But when we're adding and subtracting the same thing to both sides, it's just like it was when we worked with equations.